For this problem, we need to find a 90% confidence interval. The sample is 13, so we're going to use the variable n equals 13. Assume that the population is normally distributed. The mean weight, so the mean weight was 3 ounces. This is talking about the sample, so this is x bar equals 3. And the reason that it's talking about the sample is it's saying that a sample was selected, the weight was then recorded, the mean weight, so it's like the mean weight of these samples is 3 ounces. So x bar equals 3 with a standard deviation of 0.13. So S equals 0.13. The population standard deviation is known to be 0.1. So your sigma is 0.1. Because your sigma or population standard deviation is given, you're actually not going to use your S at all. You're not going to use the sample standard deviation. You always want to use one that is more known. So you're going to use the population standard deviation. There's less variability if you're using the population as opposed to the sample. So to construct the 90% confidence interval, the first step is to do z alpha divided by 2. Now if the confidence level is 0.90 and we are using our population standard deviation, we're going to use our normal table. So if you have your population standard deviation, use the normal table. If you don't have the population standard deviation, it's the next section where you have to use the t-distribution. So for 90% confidence, the z alpha divided by 2 is 1.645. So put that here. And the next step is standard error. Standard error is sigma divided by square root of n. So it's going to be 0.1 over square root of 13. And 0.1, so 0.1 divided by square root of 13 gives you 0.027735. Step 3 is to find your error bound for the mean, your EBM, which is your z alpha divided by 2 times your standard error. It's basically whatever you got in 1, which was 1.645, times whatever you got in 2, which is 0.027735. So you multiply that and you get 0.045624. And then the fourth step is your last step. It's your confidence interval, which is your x bar plus or minus your EBM. So your x bar is 3, and you're going to plus and minus this amount. 0.045624. Okay, so we have 3 plus x gives us 3.0456. That's your upper bound for your confidence interval. 3 minus x is 2.95438. When you round to 2 decimals, you get 2.95, 3.05. Actually, it wanted 3 decimals, so you want 2.954, 3.046. Your error bound, so this is your confidence interval. Your error bound for the mean is right here. With rounding, that would be 0.046. So it's the same process for a 98% confidence interval. The only thing that changes is your z. So your z, actually we'll just do the same thing up here. So for 98%, when you go to your chart, the z alpha divided by 2 is 2.33. So instead of using 1.645, you do 2.33. That's going to go here. 2.33 times 0.027735 gives you your 0.06462255. This is your error bound for the mean. If you rounded, that would be 0.065. And then your x bar is still 3 plus or minus the 0.06462255. So when I'm going to store the 0.06462255 on my calculator. And then you take 3 plus x, which gives you 3.0646, and you do 3 minus x, which gives you 2.9354. Let me write out more of those steps actually, because I just did it all in the same chart. Okay, so the first step is to do Z alpha divided by 2. Since the confidence level is 0.98, you go to your normal table, 0.98, the Z divided by 2, or the Z score is 2.33. Next step is to do your standard error, which is your population standard deviation divided by square root of n, which is 0.1 divided by square root of 13. Again, you don't use your sample standard deviation, you use your population standard deviation. And when you plug that into your calculator, it's the same as before, 0.0277350098. And then step 3 is to do your error bound for the mean, EBM, which is your Z alpha divided by 2 times your standard error, which is basically 2.33, times 0.02773509. So I times that in my calculator and I get 0.0646. So that is your EBM. And then the last step, again, is the confidence interval, which is X bar plus or minus your EBM. Your X bar is 3, so plus or minus 0.0646225729. You could round more. And so 3 plus X gives you 3.0646. 3 minus X gives you, or 3 minus your EBM gives you 2.9.